In our experiment today, we investigated the concept of linear momentum. This is the equation formula for linear momentum. In our first scenario, we took a hose of lower flow rate and shot it at the test dummy. In our second scenario, we took a fire extinguisher of higher flow rate and shot it at the test dummy, seeing which, if any of the two scenarios, could overcome the anchoring forces involved. In this experiment, we used the linear momentum equation to calculate the anchoring forces needed to keep the body upright. In the x component, we find that the velocity of the flow is going in the negative x direction and is going into the control volume, leading that to be negative, leading the anchoring force needed in the x direction to be rho v squared a naught. The anchoring force in the y component needed is simply the weight of the liquid plus the body. Since in scenario 1 there's a lower flow rate and scenario 2 has a higher flow rate and both have the same area, that means that the anchoring force in the second scenario would need to be larger than the anchoring force in the first scenario. That means we should predict that the second scenario is more likely to knock over the body.
This is linear momentum test number 1.
As you can see, the dummy is not tipping over.
This is linear momentum test number 2.
As we predicted, the fire extinguisher knocked over the body and the hose didn't.